Hello, Namaskar, Vanakkam. My name is Sudhir Sahasranaman, and you're watching your own channel, CBSE with Sudhir. Time to do chapter number 5 of Science Curiosity textbook for students of class 7. And this is about the changes around us, both physical and chemical, right? So, why have I put the photograph, the picture of a banana on your screen? That's because if you see the lower part of the banana, that's how a banana looks when you have got it fresh. It is ripe and it looks good, it looks beautiful, but keep it without eating it for a couple of days. That's how the top portion starts looking. I mean, the banana starts looking like what it is shown in the top portion. What it shows is that each and every object, or at least most of them, do undergo some changes over a period of time. And this is an example of a physical change. The way we are seeing it, even inside, the banana is changing in the sense that it is no longer hard, it will be a little soft. Okay, you keep it for 3-4 more days, it will start stinking, right? Which means it is kind of getting rotten and unfit for consumption. So those are also a bit of chemical changes, but physically, the way you look at the banana and say, "Mommy, mujhe nahi chahiye. I don't want to eat this banana." That reminds me, if you want to listen to the Hindi explanation of this particular chapter, please see the video in the Hindi playlist. I'm doing the explanation for the science, social science, and English chapters in both English and Hindi. Double mehnat karwa rahe ho mujhse, so that students in both the northern part of India as well as students in the southern and the eastern part of India understand in the language they are more comfortable with, which means English for South Indians and people in the eastern part of India, the northeastern part of India, because I know there are many students from the northeast also who watch our channel, and students who are more comfortable understanding in Hindi, they can listen to the Hindi explanation. Great. Chalo, kahani shuru karte hain. So this is what this chapter is going to be all about. Now, before we go, let's look at some of the illustrations in your textbook. You take out an ice cube from the freezer of your refrigerator and keep it on the table for some time. You will find in about 15-20 minutes at room temperature, irrespective of whether it is winter or summer, the ice cube will start melting. Yes, in summer it may melt faster, in winter it may take a little while longer. Okay, but eventually at room temperature, because the room temperature is much higher compared to the temperature it was inside the freezer of the refrigerator. Okay, so it will melt. Similarly, the girl says, "I saw a rose bud in the garden yesterday, but today it has blossomed and it is now a flower." So that means there is a physical change in the bud, which has now become a flower. The girl says, "The bottle containing cold water is not cold anymore." For example, I have got this particular bottle of water from the fridge. When I touch it, I can feel it is cold. But if I keep it for the next half an hour, 45 minutes, however, how much time it takes to complete this video, this water will not be so cold. Okay, it will kind of come down in terms of coldness to more equal to room temperature. Then the boy is talking about the banana, which we have already spoken about. Now you see all these different changes which are taking place around us, right? And you need to fill in your observation based on what you see. Some of these we will do a little later in the chapter, so we can always come back to it. So you see these physical changes taking place in objects around us. Anything, you put a mobile phone and connect it to the electricity thing, you will see the bars keep on moving, it is getting charged, and after a while it gets 100% charged. Isn't that so? So there is some kind of a change happening even within these kind of electric gadgets, but though that's not the kind of change that we are going to talk about in this chapter. That we have already dealt with in the electricity chapter number 3, done in both Hindi and English. Please go and see the video. The question and answers video has also been done. Now, the physical changes. A substance may change in appearance but remain the same. So let's look at some pieces of paper. I don't know how many of you have done this in your childhood when you were younger compared to what you are now. Making an aeroplane with the paper, that folding it in a particular shape, and then you करके फूक मारो and then it kind of flies a distance, or making a boat out of a paper page, right? Have you done all that? I mean, those are the joys of childhood, aren't they? Right? So when you do that and when you remove it and put it back, unless you have cut the paper will come back to its original shape, right? So that may depend on the paper, right? But if you cut it, obviously it cannot be, the physical shape would have changed. Even this, you have a plain sheet of paper, but you are making a boat or a plane with the help of that plain sheet of paper. So the physical shape, in a sense, is also changing, right? Like a bird has been made out here, right? Boat has been, like, this is a boat, this is a bird, this is an aeroplane, right? So different kinds of things which have been made. Now this is a very nice looking peacock, this is also an aeroplane, this is also an aeroplane, right? Now what you do now is to talk about a balloon, now you have a proper shrunk balloon, you get it in a packet from the store, from the market. This is how it looks on the left hand side. Okay, then you hook maro. Okay, you exhale air into it, and this is what it ends up looking like. But then you prick it with a pin and it goes back and becomes a deflated one, but it cannot be inflated again because now it has a hole in it, right? Through which the air will leak, so it can never be brought back to the shape of A. So A, B, C. So B cannot be brought because it has got deflated. So physical changes is that no new substance is formed. From this, we are only filling air, but there is no change in physical substance. The substance is not changing. Just like in the paper is remaining the same, only the shape is changing. So such changes in which only physical properties like shape, size, state of substance changes is called physical changes. Physical changes are changes in which only physical properties like shape, like paper, is turning into a boat, it is turning into a bird, right? Or the size, for example, this particular balloon, the size is this much, but when you fill in air, it becomes this much. So the size of the balloon is changing, or the state of the substance is changing, right? That is called a physical change. The next we move to, okay, then similarly you have a crushing a piece of chalk. You crush a piece of chalk, the shape and the state of the substance has changed. It was solid, but now it has become some kind of powder, right? So that is the physical change. Now the second one is a substance which may change in appearance and not remain the same. Now what you need to do is an activity for this. Take two glass tumblers which are, one second, I'm just also editing at the same time. So take two glass tumblers which are transparent in nature, and mark them as A and B. Okay, so what you do is that the first one that you see on the left hand side, page, you do it and you put a straw, and this contains normal tap water. The second one is containing lime water, and please be clear that you cannot inhale that, you cannot drink that. So this contains lime water. So here you are again exhaling. When you are exhaling, you are leaving out what gas? Carbon dioxide. So when you leave out carbon dioxide, do you see a change? So when you put the thing out there, we realize that carbon dioxide plus lime water turns it into milky, whereas there is absolutely no change in the color or the texture of tap water. Or your aquaguard or whatever kind of mineral water, whatever you have, right? Of normal water, there won't be any change. But when it comes to, I'm simultaneously also editing what I had recorded earlier in the day, so that's why I'm putting it both, so that I don't have to spend time later on. So it kind of turns milky in texture. You can see that it becomes more like milk. The first one, water, will remain the same. These are called chemical changes, because what is happening is that carbon dioxide added with lime water is resulting in a chemical reaction. Okay, and that is what is leading to the change in the look and the texture of that particular lime water. Because what is happening, and what is this white color substance? It is calcium carbonate. The chemical formula is CaCO3. Ca is calcium, carbon dioxide, right? So that's what is happening out here. So a new substance is getting formed whose color is milky. Okay, so this is the formula: calcium hydroxide, which is the formula for lime water, carbon dioxide, which you are exhaling into it, and that results in calcium carbonate, what I just now told you, CaCO3 plus H2O. This will be the chemical formula. All this you have to study only in class 9 and 10, mainly in class 10. Now let's do one more experiment for carbon dioxide with which you will understand. What you are to do is that there are two test tubes. These are called test tubes. So in the first test tube, you are going to put vinegar and baking soda. Okay. The second test tube, you're going to put lime water once again. So what you do out here is that you pass this gas through freshly, whatever gas is being formed out there. Okay, whatever gas is being formed out there, which will be basically bubbles of carbon dioxide, it passes through here and gets added to the lime water. What will happen? That the lime water, like what it shows here in these bottles, it will turn milky in color, right? So whatever gas, so that means the gas which has been formed is carbon dioxide. This is a test to see whether which gas is being formed, and because it is turning milky, now we know that the gas which has been formed is when vinegar is added to baking soda, it is carbon dioxide is the gas which is formed, right? So vinegar, usme baking soda dalo. So the gas which is formed, we don't know which gas is formed. So the test we are doing is to mix it with lime water. When it turns milky, now we know that it is carbon dioxide. So that is how you, this is how the tests are done in the chemical laboratory. That is vinegar, which is used for cooking purposes also. Baking soda, again used for cooking purposes, releases carbon dioxide and other substances. Now, the third one is about rusting, about which we studied in the previous chapter. That is the metals and the non-metals chapter. I hope you remember that rust is formed, which is basically on iron. Corrosion is on other substances like silver or magnesium, etc. So these are the rusted nails. Like nails, if you leave it in a place where there is moisture and air, moisture in the air, there you will find the nails become dark brown deposit on the nails. That is called rust. The fourth thing which you have to study is combustion. Let me quickly do a recap also. This is what it is, because I've made this beautiful PPT and I'm very happy with the quality of the PPT. Look at the quality of the illustration. So carbon dioxide turns lime water milky, and this can be used as a test to check the presence of carbon dioxide. What are the other processes? During rusting, a new colored, brown colored substance called rust is formed. Here you see these are iron chains which have all got rusted. It is a chemical change because it involves the formation of iron oxide. Oxide, the presence of air. Then let's come. This is something which I had mentioned briefly in the previous chapter also on metals and non-metals, where we are using a magnesium ribbon, right? So combustion, what is combustion? We have already studied about combustion, combustible substances, etc. in previous chapters. So a chemical reaction in which a substance reacts with oxygen and produces heat, it produces light. That's called combustion. This is the definition which you need to remember. Okay. So wood, cotton, paper, kerosene, dry grass, these are all combustible substances. Let's go through each one of them. Wood, लकड़ी को जलाते हैं. You burn wood in order to create fire. Why? Because wood is combustible. It can catch fire. Cotton, a cotton shirt will easily catch fire, right? So cotton is combustible. Paper, you can burn paper easy, you know that. Kerosene, obviously you use kerosene as a fuel also, right? Dry grass, if you put grass which is dry, wet grass will take time to burn, but dry grass, if you put a matchstick on it, it will burn immediately. Why? Because all these are combustible substances. So that is something which you need to remember. So this is what is combustion. So when this magnesium ribbon is burnt, a new substance is formed, which is magnesium oxide. I've shown this out here. The powder that you find out here is magnesium oxide. Magnesium plus oxygen is forming magnesium oxide. So it is also involving a chemical change. We observe that heat and light are produced. So magnesium plus oxygen, magnesium oxide, which is the white powder, and also heat and light are produced as byproducts of this chemical reaction. So a chemical reaction in which a substance reacts with oxygen and produces heat and light, sometimes heat or light, is called combustion. Okay, so simple thing now. You burn wood. Okay, when you burn wood, what happens? It is producing light, it is also producing heat, right? So in most cases, heat and light both are produced, right? So that is something which you need to remember. Now, substances that undergo combustion are called combustion reactions, are called combustible substances. I've already mentioned that to you. Now let's do an experiment. Let us burn 2 candles, okay, on 2 petri dishes. Now this is a petri dish. We are burning a candle. But in this case, we put a glass tumbler to cover it. What we will find is that this particular candle gets extinguished. Okay, it will not be able to glow for a time within few seconds because there is no oxygen available to it. This is an experiment to see what is required. But I'm telling you that because there is no oxygen, it will get extinguished within a matter of seconds. Okay, so what happens? So the candle which was not covered continues to burn. Why? Because it is getting a steady flow of oxygen around it, right? Whereas the candle that was covered by a glass tumbler is extinguished. It stops burning after a while. Since the candle covered by the glass tumbler does not have a continuous supply of air, the flame gets extinguished. So the component of air that supports combustion is oxygen. This is something which is why in fire extinguishers that you keep inside your building, etc., do you know which is the gas which is there? Can you put oxygen in it? Obviously not, because if you put oxygen and then you try to extinguish the fire, no, it will catch fire even more, right? So never make the mistake of filling in oxygen inside that fire extinguisher cylinder. It should contain carbon dioxide, because carbon dioxide does not allow the fire to go on for too much time. So there is carbon dioxide out here inside the tumbler, and that does not allow the fire to go on. Now, how do you test the carbon dioxide? Let's test everything. No, we are in science, so we need to test everything. So what we do is that we add a bit of lime water to the petri dish on which the candle is kept, and we see that turns milky. And the moment it turns milky, we know it for a fact that carbon dioxide was the gas which was formed by the carbon from the wax and the oxygen from the air. That is, from the wax you get carbon, and plus O2, it leads to CO2, that is carbon dioxide. In other words, it means that for combustion, oxygen is required. I'll give you another example. For example, if there is, what happens? Sometimes there are forest fires. I'll give you practical examples which I have covered. There are forest fires, which means on the mountains in the forest, it catches fire. Somebody would put a lit cigarette out there, or somebody would light a fire and leave it unattended without extinguishing it, and the whole forest catches fire. So what has happened? I remember it happening in Himachal and Uttarakhand, and even in USA for that matter, helicopters would be sent with lots of water in it, so that their thing it will go over the mountain and put water on the fire and extinguish it. Fine, the water will do its job, but you know what will happen? Because the blades of the helicopter, they will it will move around in the air, and they are moving the oxygen and the air. the fire will actually catch on even more. So thereafter, helicopters were seen as a bad idea to be used to put out forest fires, because the moment you get an helicopter, the air circulation increases, as a result of which the fire gets the oxygen to burn even more. Right? You understand the point? I'm giving you a practical example. If I were your teacher, I would give you questions like this so that I test your knowledge, your understanding, your application of what I'm teaching you. Not like, see the what is the definition of combustion, that they may ask, but what I'm saying is that you need to be able to practically understand. Similarly, if a man has caught fire, let's assume that tragedy has happened, a man has caught fire, he runs in panic. Obviously anybody in panic will run, but the moment he runs, he's disturbing the air around him, and the moment he disturbs the air around him, that actually increases the amount of fire that is catching on his body. So the best thing to do, I know it's easier to say, but the best thing to do when you catch a fire, when somebody catches a fire, is to roll on the ground to try and kind of extinguishing it. Unless you can get some help in the form of water or somebody coming and putting a thick blanket around you, that's different. But please understand, the moment you run, you're actually increasing the chances of you catching fire even more. Okay. Now, yeah. Now, what is the way? What I just now said, blanket, and also the quality, because if it's a thick blanket, the chances, whereas if you try to cover somebody with this cotton kind of shirt, it will catch fire. So you need a thick woolen kind of blanket in order to ensure that the person does not catch more fire. Now let's come to some fascinating fact, and I will show it to you in the same. Have you ever gone late after sunset, late, I mean a little 7:30, 8 kind of thing, and especially in a more deserted area, highly unlikely you will find it in urban areas. You see this kind of things, you will see these kind of lights which are glowing. Now when you see light which is glowing, what are they? They are actually called fireflies. Okay, they are actually called fireflies, and from a distance you will see as though the forest or the dense area is kind of getting illuminated. What is really happening out here? Let's explain this fascinating fact. Now this is a wonder of nature. You might have seen some insects emitting light in a garden or a field in the late evening. Now these insects are called fireflies, and their light is produced by a chemical change. There is a chemical change happening inside them. Okay, this is just a mention here. We're not getting into too many details because that's for higher classes. And this type of chemical change, as a result of which light is getting produced, and you're able to spot the light, but without heat. In this case, there is no heat produced, only light is produced, unlike in a fire. In living organisms is called bioluminescence. So you may get an example of this kind in your exam, and you may be asked to explain what really happens. Okay. Now, is the presence of air enough for combustion? Like, if you just have air, is it good enough to form combustion? Not really. Air is not the only thing that is required for combustion. You need many more things. Yes, you need a combustible substance. Of course you need. Otherwise, if you try to burn something which cannot be burned, then even air will not really help you. You try to burn a metal, for example, which cannot be burned, then even if you have air, that will not help. So let's learn about this. So what do? We do an activity. I'll show it to you with the help of a beautiful photograph. We are going to burn paper. Paper is what? Paper is a combustible substance. Now, one way of doing it is to take a matchstick and burn the paper. Swaha, khatam ho gayi kahani. Okay. Now, we do something more interesting. We take it out into the sunlight. It is, let's say, 12 o'clock, 1 o'clock in the daytime. Okay. I want you to get a microscope. A microscope kind of a thing, not a microscope. What am I saying? A magnifying glass. Sorry. This is a magnifying glass. Okay. Now what you do is to put the paper, bright sun. Okay, hot sun, not a cloudy day. Bright sun, and you try to catch the sun rays in the magnifying glass. Okay, you put it at an angle where the sun rays, like where you are seeing, the sun rays are hitting the magnifying glass. Please see the screen there, and then you focus it on the paper and keep it for some time. It may take a few minutes depending on the heat of the sun rays. Suppose it is a cloudy day in the month of November, December, it may take a long while because it's a winter month. But let's assume you are in the month of April, May, when it is harsh summer and you are going out in the afternoon sun, 12, 1, when it is at its peak. At that time, you focus the 1 o'clock or 2 o'clock sun rays on the magnifying glass, and through the magnifying glass on the paper, you will find that the paper will start burning after a while. You can see it in the picture that I've created. It will start burning. So focusing sun rays on paper heats up the paper, increasing the temperature of the paper, and the paper eventually starts burning. I hope it's clear. Now, what is the science happening behind it? The minimum temperature at which a substance catches fire is called the ignition temperature. The minimum temperature. The minimum temperature. It's far more easy when you're using a matchstick and lighting up a paper, right? But in this case, you are using an indirect method of catching the heat of the sun rays coming from light years away from the earth, and catching it on the magnifying glass and then focusing it on the piece of paper and making it reach a particular minimum temperature, which is called the ignition temperature. Now, that's what is happening. It will start emitting smoke and eventually catch fire. Now, you may say, what happened in the case of a matchstick? This is what happens in the case of a matchstick. Since the temperature of the lighted matchstick was already higher than the ignition temperature of the paper will have a minimum ignition temperature. But the fire's ignition temperature, the temperature of the lighted matchstick, the fire of the matchstick will be much more, so it catches fire immediately. Whereas this will take a bit of time. So what do you need? So that means for the combustion process to occur, you need three things. You need oxygen, air. You need a combustible substance, which can be paper, it can be dry grass, it can be wood, etc. And you need the heat that allows the combustible substance to reach its ignition temperature. Is it clear? Great. So these are the three things you need. You need oxygen, you need the combustible substance, and you need the source of heat. Okay, it can be a matchstick or it can be this kind of capturing the rays and the heat of the sun. Now, the next one is, can physical and chemical changes occur in the same process? Now, this is very interesting, and we are going to do this with the help of an experiment involving a candle, a burning candle. Now, you see a candle. I don't know whether you are, आजकल तो inverter का ज़माना है, so you may not be used to power cuts and keeping a candle in the middle of the house to give you light. All that we have seen in our childhood, your parents would have seen. Anyway, so you have a candle, right? So in the candle, there is a wick, that is a black thing, the thread on top of the candle, and then there is a candle which is made of wax. So let me show you, which I have done. Now, can physical and chemical changes occur in the same process? Now, this is a candle which is happening. When a candle burns, the physical change, I'm going to first talk about the physical change, then I'll talk about the chemical change. When a candle burns, the physical change, that is physical means what you're seeing, is that the wax melts near the flame. The wax which is around the flame, because of the heat of the fire, the wax around the flame starts melting and steam keeps going down like that, right? There is no new substance which is being formed. Wax is turning from a solid to liquid, and it will again solidify and become solid again, though in a slightly different shape. That's what is a physical change, right? If it cools down, it becomes solid again, what I just now said. Only the state, solid to liquid to solid, changes. That's all. Nothing else changes. But at the same time, there is also a chemical change which is taking place. The chemical change which is taking place, you see the vapor that is there above the light of the fire. The chemical change is that the liquid wax, the wax which is there just around this, in this kind of area, the liquid wax near the wick is this black thing. Wick is this black thing in the middle, right? The liquid wax near the wick, it turns into vapor. Okay, this vapor, what you're seeing out there, that smoke which you're seeing, this vapor, it reacts with oxygen in the air and burns. That's why you're seeing the production of heat and light, producing heat, light, and carbon dioxide. water vapor. The burning is a chemical change because new substances are being formed. Carbon dioxide is being formed, heat is being formed, light is being formed, water vapor is being formed, and that cannot be reversed. Whereas in the physical change, the wax is turning from solid to liquid and again becomes solid after a while, right? When it cools down. So that is a physical change. This is a chemical change. So both can happen in the same experiment, and the candle experiment is an excellent way to show what really happens. Now, I've already, because I was not very happy with the explanation given there, which is why I've explained it in much more simpler and clear terms. Now let's know this particular scientist called Michael Faraday. Now Michael Faraday actually experimented a lot with a candle in order to understand the chemical history of a candle, because he believed that candle was a perfect object to understand different sciences, and you're able to understand both physical and chemical process like melting of the wax, the vaporization, and the combustion process. So he realized that three things: melting, combustion, and vaporization, all three things you are able to understand by using a wax candle. So this is Michael Faraday, one of the very well-known scientists. Okay. Now, then it comes about, are chemical changes permanent? Ki ek bari what has been changed, திரும்பி பின்னி change பண்ண முடியுமா இல்லையாதா? So other than about that, we need to understand whether changes are permanent. In some cases, changes are permanent. In some cases, changes are not permanent. They are temporary. Okay. So here there are some examples like melting ice cubes. Let me show it to you with the help of my thing. Like for example, are changes permanent? When you cut, let's say a vegetable like okra, bindi, ladyfinger, right? When you vandakai, when you cut it, right? It is getting cut into smaller pieces. Can they all be joined back together to form the same one? Not really. I mean, they remain as ladyfinger, as okra, as bindi, as vandakai, but vandakai is what bindi is called in Tamil. But the shape changes. It is in small pieces. What a beautiful illustration, right? So this is how. Ice cubes, no, they melt from solid to liquid, right? Can they become solid again? Only if you put it back into a freezer. Isn't that, my friend? Only if you put it back into a freezer, it will change. Otherwise, it will go from solid to liquid. Popcorn, you get it in the form of corn, then you put it in a vessel, you put the fire and do all that jazz, you cover it, tap, 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 sound will come, and then you mix some salt and you get fantastic classic salted popcorn. Tasty, yummy, right? So that's what is popcorn. Now there, the entire shape, everything is changing. Are this change permanent? Yes, it is permanent, because the popcorn that you have got now, the white color popcorn, it cannot go back to the form of the chota wala golden color corn again, right? So this change is permanent, right? Ice cube also is permanent in a way, because unless you put in a freezer, you cannot get the ice cube back again. If you put it, you will get it, right? So that is the thing about the whether the changes are permanent or not. So that's what it's saying. Ice melts, it can be refrozen into ice by putting it in the freezer. But some changes are not permanent. For example, chopped vegetables cannot be returned to their original shape. Popcorn cannot go back to its original form. So those are the changes which are permanent. Are all changes desirable? Like, okay, we talk about various changes, but are all changes desirable? I mean, must hai kya? Not really. There are many changes which are not good, which are actually harmful to the environment around us. For example, the rusting of iron is not good, because then that iron piece you may not be able to use. Similarly, if you keep the food outside in the heat in the summer months, forget to put it inside the refrigerator, you will find that by evening that food has got spoiled, it has got rotten, it is not fit for consumption, you cannot eat it, it will give a very bad smell, right? So certain changes are certainly not desirable, right? There are some changes which also occur due to human activity over a long period, and this pertains mainly to environment, right? For example, we use a lot of fuel that adds to the pollution, so the air quality around us is actually very bad. For example, there are certain cities like Delhi, what happens when there is smog during winter, the air quality index goes down, AQI is really going down. So as a result of which you find breathing very difficult. You have those kind of machines put inside home to improve the AQI. Similarly, when there is burning of crops, etc., the pollution increases. from factories. If you live near a factory, you will find the entire quality of air near your house is a little bad because there is pollution from the factories. So the whole idea is that there are lots of things, even paint for that matter, air conditioners for that matter, it's increasing the heat around us. So outside, inside you will be cool, but outside you are generating heat, so you are actually adding to atmospheric pollution. So certain changes are not desirable. Okay, now there is also a case of some natural changes which take place over many years. Okay, one of them is called the weathering of rocks. Now what happens here, is that there are these rocks. Now especially if there are water, some of them may crack over a period of time due to heat, due to earthquakes, due to some water stream flowing through it. For example, in this one you see the water stream flowing. What happens is that as a result of which, when water keeps on flowing, it will change the shape of that particular rock structure, because water is very persistent. So it will shape, it will make it soft, but it will also change the shape of the rock. So as a result of which, over many years, it will not happen like Monday to Friday. No, over many years, the shape of the rock will change, and this is called weathering of the rock. So physical and chemical changes in rocks are called weathering of rocks. And as a result, you see that the rock shape from this, it has gone to this, it can even go underwater like this. So that is what happens over a period of time. So when you see many soils and small pieces of stones, etc., at the base of the mountains, how did they arrive at the base of the mountains? They have come from top. From top, they have got broken due to weathering of rocks. Is come down and it is lying at the bottom of the mountain, and there they are called as sediments of those rocks. They are formed because the bigger rocks have broken into smaller pieces. It could be because of temperature change, it could be because of water, it could be because of sometimes because of roots growing and then breaking the rocks. That can also happen. So because of all these changes, weathering of rocks can take place. Also, water or the chemicals which are present in water, right? They can also react with rocks, and they can cause chemical changes in the composition of the rocks. So one of the example is an originally black colored rock which is called basalt, okay, which contains iron incidentally. Now that has chemically changed to convert into a red color layer, okay, a layer over that rock. The red color is because of the presence of iron oxide. Every time remember iron oxide, like it is in the case of rust, it will produce a reddish brown color. Okay, so because that surface of the rock was exposed for a long time to water or air containing water vapor, it will kind of change in color. And this is in the case of rock, since it's not iron, since in the case of rock, it is called the weathering of the rocks, and that also changes the formation of the soil in that particular area. Now you see in this photograph at the bottom, you are seeing some brown color, okay, reddish brown color. Then finally we come to erosion. I had used this photograph in another video also. Here you are saying that, a large portion of the soil has given way, it has fallen down. So when rock pebbles, soil are broken down and are moved from one location to another by natural forces, it could be an earthquake, it could be a landslide, it could be flowing water, it could be the strong winds, etc. That is known as erosion or soil erosion, because what is happening is that the roots of these trees have not been able to hold together the rocks, the soil, and it kinds of gives way. So what is happening is that all this sand and soil comes down onto the river level, at the ground level it comes. So erosion which takes place during a landslide, which happened, for example, in Uttarakhand in 2013, you find, I remember going to Yamunotri at that time, and large areas had just kind of fallen off, right? So then what happens is that it becomes very difficult. So erosion during a landslide, I think I've used a photograph out here. No, I erosion during a landslide is an example of a physical change. River rocks and pebbles, I had used it in the climates of India explanation video. Please see there. River rocks and pebbles, when I was on my way to Yamunotri, river rocks and pebbles often appear smoother. What happens is that if you ever go to a river bed, you will find many stones. You will find always those stones are absolutely round in shape. How have they become round in shape? Because water has continuously flowed, and that changes the shape of the stones and makes it absolutely round in shape. It is very smooth, right? So they are, river rocks and pebbles are smooth because of constant erosion, because of the flowing water, and the water has its kind of force. So these sediments, subsequently these sediments all harden and they become new rocks. So rocks break, they are broken into sediments, and these sediments together, they keep coming together and again form some kind of rock. So these are like long kind of process which cannot be reversed, but they keep changing over a long period of time. It's not something which happens in 1-2 years, but over long years, decades and centuries. So with that, we come to the end of this particular chapter. Now you see, this is the ice cube thing which I had shown you. This is the apple. If you cut the apple, can it be put back in the same shape? It is changing its shape, so it is a physical change. Here you see a nice yummy sandwich being taken apart. Now there is a physical change. You will eat it off, but it cannot be brought back together because you are splitting it into two halves. So with that, we come to the end of this chapter. We will do the question and answer separately. As I said, the Hindi explanation video has already been done. Thank you very much. Share the video and subscribe to CBSE with Sudhir. Share the video with your friends so that more and more friends of yours, batchmates, juniors next year, come to know of it. Thank you very much. Tata. Bye bye.